ለመማር ወደ ትምህርት ተቋም መሄድ ግድ አይደለም።
ናሽናል አቪዬሽን ኮሌጅ
ራሳችሁን ከኮሮና ቫይረስ ወረርሽኝ እየጠበቃችሁ በቤታችሁ ወይም በተመቻችሁ ቦታ
በኢንተርኔት አማካኝነት በኦንላይን ትምህርታችሁን መከታተል ይቻላል።
ካናዳ ከሚገኘው ኢንተርናሽናል ኤር ትራንስፖርት አሶሲዬሽን አያታና
ከእንግሊዙ ኢንስቲትዩት ኦፍ ኮመርሻል ማኔጅመንት ICM ጋር በመተባበር የሚሰጡ ትምህርቶችን ተከታትላችሁ በ6 ወር ጊዜ በዓለም አቀፍ ደረጃ ተቀባይነት ያለውን የስልጠና ማስረጃ ባለቤት መሆን ይቻላል።
ከኢትዮጵያ ሲቪል አቪዬሽን ባለስልጣን ሙሉ ዕውቅና ባገኘንባቸው የፍላይት ኦፕሬሽን እና የሆስተስ ስልጠናም በምዝገባ ላይ ነን።
ጥያቄና መልስ፣ የክፍል ስራዎች ብሎም ፈተና መፈተን ክፍል ውስጥ እንዳላችሁ አይነት
ልምድ ባላቸው መምህራን እየተማራችሁ
በኦንላይን ባላችሁበት ቦታ
አድራሻ ከ22 ማዞሪያ ወደ ሾላ ገበያ በሚወስደው መንገድ 150 ሜትር ገባ ብሎ ናሽናል አቪዬሽን ኮሌጅ
የናሽናል ኤርዌይስ እህት ኩባንያ
ህልሞን እውን ያደርጋል።
ወደ 5 ደርሳችኋል። ሰላም ናችሁ አይደል?
እግዚአብሔር ይመስገን።
So last week, almost last Tuesday or before 10 days, we have seen chapter 2, which is a foundation for risk analysis, especially in order to have a quantitative analysis, risk analysis. That was a good basis. And as I say, that at the end of that section, I told you that there are 2 or 3 slides left, and I suggest you to read as it has less important. Today, we will start chapter 3, and starting from this section, we are going to apply different risk analysis tools, especially we will focus sharing with that. Let's share.
ይታያል።
All right. So thank you. So starting from this chapter, we will have both theoretical and quantitative analysis, or we can say a practical risk analysis. And this chapter is all about risk and risk analysis, and we will consider different tools in risk analysis process. And the main objective of this chapter is to give a different approach, especially the fundamental approach to risk and risk analysis, based on the concept that risk is a way of expressing uncertainty, right? Sablonge, last time you asked me about the difference between risk and uncertainties, and that was all about the relationships. And here we are going to express uncertainties in terms of known number and known possibility of occurrences. So we could say that the entire part of this chapter is based on the underlying concept that the risk is a way of expressing uncertainty related to future observable quantities. We will see what are these quantities in fact. So first we will discuss about the basic ideas and basic principles in risk analysis. So we should start our discussion or in the risk analysis. The starting point is the so-called activity. There must be activity, and then based on this activity, we are going to predict the uncertainties or related with this activity. The activity may be a kind of investments, or a kind of design, product design, or it's a kind of operations, right? And operations. So we will have different activities that should be measurable, right? That should be measurables. And these activities may be measured in terms of profit, in terms of production volume, in terms of production loss, or we can say for a kind of accident-like risk, the number of fatalities, or we can say that the number of injuries, right? The number of injuries. So the way we measure, or the measurement for activity, is in fact depend on the nature of the activity itself. We measure investment in terms of profit, product design, or we measure operation in terms of production volume, or different things, right? And as I said before, we can measure risks related with accidents in terms of facilities and injuries, right? Injuries. Now, once we have activity and once we have a means to measure these activities, we have to quantify, right? We have to quantify, which means performance measures of the activities are the quantities used to give decisions, right? The quantities used to give decisions as they provide information about performance of the alternatives. So an important thing here is performance measurement for activity means it is all about assigning quantity which is useful for decision making, right? Decision making. Now, in order to change the issue into risk analysis, unfortunately, the quantities or measure of activities, let it be maybe profit or maybe production loss or maybe number of fatalities, they are unknown while we, or at the time when we take decisions. So here, think about, we have activity, we have measurement of the activities, and we have to quantify activities, that is measure of performance. But taking this concept into risk, we don't have a clearly known amount of performance. Let's say amount of profit, amount of production or level of productions, or amount of fatalities while we take decisions. Therefore, if we are not certain about the quantities of performance, what's left is we have to predict the quantities for decision making, right? We must have quantity for decision making, but we don't know the exact quantity. So the alternative at hand is to predict those quantities, right? Those quantities. So we can make rational predictions. Unfortunately, predictions will not normally provide sufficient information, right? Sometimes the predictions may not provide adequate information for decision making. So what is left? Once we fail to predict accurately, we have to go to the concept of uncertainties. So we have to measure uncertainties, right? Uncertainties. Measuring uncertainties means it is go beyond expectation, right? We have to go beyond expectations. So in this slide, you have to remember 4 important things. In order to make risk analysis, we should have activity. And that activity should be measurable, right? Should be measurable. But the activity on hand or the performance of the activities, what we have on hand is uncertain. It is not certain and may not be adequate to use for decision making. If it is inadequate, we have to predict. And similarly, prediction has also its own limitation. Our prediction may not be accurate or maybe provide insufficient information for decision making. So what's left is we have to measure uncertainties, right? Uncertainties. We call it go beyond expectation, right? Go beyond expectations. Now, for example, we may expect the value, or let's say that the expected performance of the activity, assume we expect the value or our prediction for a given performance is assume 1.5. We predict 1.5. It may be ratio, it may be amount, or it may be something. Anyways, our prediction about a performance of an activity is assumed 1.5. But when the time goes on, or when we arrive the time, or when actually the actual outcome may not be the same, or may not be equal to our prediction. It may be less than, or it may be greater than. For example, the outcome or the true outcome may be 0, less than 1.5, or maybe 5, greater than 1.5, or maybe 100, very greater than 1.5. So in such case, the assessment of uncertainties related to each possible outcome may provide adequate information. So here means we have to assess the uncertainty of each outcomes, 0, 5, and 100. And so that we may obtain sufficient information to compare the actual value with the expected one, right? The expected one. In order to express our uncertainty, we need to measure a probability based on a certain standard, right? So in order to express the uncertainties, to what extent the true outcome will be 0, to what extent the true or the actual outcome to be 5, to what extent the actual outcome will be 100. To do this, we have to compute probability, right? Probability. And the determination of probability must be based on a certain standard, right? Must be based on a certain standard. Now, let's say if the possible outcomes are 0, 5, and 100, as we mentioned here, we may assign probability figure. Say the probability of the actual outcome to be 0 is 0.89, or we can say 89%. We may assign the probability the true outcome to be 5 is 0.1, and the remaining 0.01 is the probability the actual outcome to be 100. So the corresponding degree of belief, or we can say this assignment is based on our belief, right? Our belief. And the assignment probabilities cannot be computed randomly. It should be based on the our belief, degree of belief we have in different values, right? In different values. That's why we give higher probability for the outcome to be 0, and the next higher probability to the outcome to be 1, and the least probability to the outcome to be 100, although our prediction is 1.5, right? 1.5. Now, one thing you have to remember is the assignment of probability 0.89, 0.1, or 0.01 is based on the availability of information and our understanding about the situation. That's knowledge, right? That's knowledge. The more we have better information, we could able to predict with certainty, right? With certainties, which means in the assignment of probabilities to the occurrence of an outcome, we must consider information, the availability of information, and our knowledge, right? Our knowledge. Unfortunately, the knowledge at hand, or the knowledge we honed, and the information at hand is often limited. In frictionless economy, or we can say that in uncertain situation, we know very little about the possible outcome of an event, and we know little about the situation. So both our knowledge and acquisition of the information is limited. We call it asymmetric information. We do have asymmetric information, right? We don't know how people behave. We don't know how the machine operates, right? With certainty. So there is limitations, right? There is limitations. So if the assignment of the probability is based on the available information and the knowledge, and our knowledge and information is limited, so what can we do to have a reasonable or a kind of little bit a certain prediction of risks or expectation about the future? So the best way at hand to deal with such problem is to develop a model, That is the use of system analysis and modeling, right? The use of system analysis and modeling. Using system analysis and modeling is supposed to be or believed to provide adequate information and supposed to have increase our knowledge about the understanding of situation, right? In fact, in some cases or in some situations, using system analysis or modeling may increase our uncertainty to predict the future, right? Which means indicating even though the use of system analysis and modeling is better to assign probabilities under a condition of limited information and limited knowledge, we still have situation where the use of such analysis and modeling could increase the uncertainties, indicating there is no perfect means of predicting the future, right? There is no perfect or certain ways of quantifying future outcome, right? Future outcome. So we are talking about relative advantage or relative perfectness to predict the future outcome, right? To predict the future outcomes. Now, whether we make analysis based on available information or whether we use system analysis or modeling, some econometrics model to predict the outcome or the situation, the important concept here is we have to make a rigorous analysis, more detailed analysis under different scenarios, analysis under different situations, may able to provide better information so that the assignment of probabilities for uncertainties would be better, right? Would be better. Now, a general concept here is normally we would be very far away from being able to see the future, right? With certainty. But the principle is important issue. We must have some important principles to deal with uncertainties related to the future, quantities or business, right? That means we can say uncertainties related to the future, observable quantities are epistemic. Epistemic means, which means it is due to the result of lack of knowledge and lack of information, right? Lack of information. Now, let us see some of the principles, right? Let's see some of the principles used to have or some of the principles that used to obtain sufficient information and better knowledge about the occurrence of an event, right? The occurrence of an event, which used to assign probabilities, right? Probabilities. So we will go, here is a time to see what principles we have to consider in risk analysis, right? In risk analysis. So the following are the main principle of unifying approach in the risk analysis. Unifying approach means they are mostly used approaches or a common approach in risk analysis, right? So we have 4 principles we have to consider risk analysis, especially when we assign probabilities for the uncertain outcome, right? The uncertain outcome. The first principle or the first assumption is there must be observable quantities, right? There must be observable quantities, which means a quantities expressing the state of the world or state of nature, right? The state of nature, which are unknown at the time of decision making, but we could reasonably estimate it to the future, right? To the future. If the system being analysis is actually implemented, we can know or we can predict the outcome of the observable quantities, right? Quantities. right? Which means a value of the future, which is possibly known to the future, right? To the future. So in risk analysis, the first principle is there must be observable quantities. We must quantify, or the thing we are going to assign probabilities, or the thing we are going to measure relationship between different situations. Let's say Y, the explained, and X, the explanatory. Both the right side and the left side of the model must be quantified. Otherwise, we cannot assign probability for uncertainties, right? Uncertainties, which means we cannot separate uncertainties from risk, right? Uncertainties from risk. So there should be observable quantities. That means there must be measurable outcome, measurable inputs, right? Measurable inputs. The other one is measurable quantities are predictable. That is the important thing. These measurable quantities, we don't know the exact or the actual value today, but we are going to predict it. So the quantities must be predictable, right? The observable quantities should be predictable. We can predict reasonably to the future. The third principle is uncertainty related to what values the observable quantities will take it expressed by means of probabilities. This is also the most important principles. The uncertainty is, which means the unknown outcome. The outcome is unknown, and this uncertainty must be explained in terms of probability, right? Should be explained in terms of probability. Unless and otherwise we assign probability for uncertainties, we cannot measure risk, right? We cannot measure risk. So the third principle is uncertainty related to observable quantities, the quantity that we want to know actually, right? Observable quantities means the quantity which is unknown today, but can reasonably estimate the future, should be expressed in terms of probability, right? Probability. So this is the third principle. And the fourth principle is models in risk analysis contexts, right? Which we should convert into the model. Last time I told you that the model is a kind of something to be used for to investigate the relationship between some variables. The model are simplified representation of the world, right? The model is simplified explanation of the world, which is deterministic function, linking observable quantities in different level of detail, right? Observable quantities. The observable quantities are y and x, assume the dependent and the independent variables. They explain and explanatory variables. So the model is, it is somewhat indicating the relationship between these observable quantities, right? Observable quantities. So these four principles you should remember in risk analysis approach. They are not the only principle, but the unifying approach in risk analysis. So the four principles are, there should be observable quantities, right? Observable quantities. Observable quantities means the thing we want to know to the future. We don't know exactly today, but we can predict the future. And these predictable quantities, or these observable quantities, should be predictable, right? Should be predictable. And in prediction, or in predicting the future, we have to use two concepts, uncertainty and probability. So the third principle is uncertainty related with observable quantities should be explained in terms of probability. We must be in the position to give probabilities of the occurrence of the observable quantity. And the last one, we must able to develop a model to show the deterministic relationship between observable quantities y and x, right? Y and x. We can express this relationship in terms of figure, right? In terms of figure. So you have to start from here. The first principle says here, observable quantities. See here, the world or the state of nature. Observable quantities are what? Y. This is the item affected by X. The factors may not only be 1. So we may have X1, X2, Xn. So these are observable quantities, right? Observable quantities. We don't know certainly the value of Y, right? We don't know certainly the value of Y, but we can predict using the value of X, X1, X2, X3, right? Predict. So going here, risk analysis, understanding of the world, right? In the analysis or in making risk analysis, we should have some understanding. We must have some informations. For example, background information, including phenomenological knowledge, experience, data, or operational experience, right? This is phenomenological knowledge, the knowledge we obtain from existing events or the thing that already happened. Experience data, we have the data based on this data is historical because it's based on past experience. Or we may have operational experiences, right? Operational experiences. And this help us to assign uncertainties, right? We should take uncertainty assessment, right? Uncertainty assessment. That is making simplification, right? Simplification to develop a model. And the same time, we can develop a model. Y is a function of X. This is in fact a kind, whether it might be linear relationship or non-linear relationship. So we are going to develop a model which shows the relationship between observable quantities Y and X, right? And X. The model and the uncertainty together used to assign probabilities, right? Probabilities. Using the model and assessment of uncertainties based on this information, we can calculate probability, right? Probability. Once we predict the probabilities, that is, we give weight, we give the numerical value to the occurrence of an event, right? So that we can make a prediction. Prediction means we can predict the model in quantifiable form, right? How X affect Y, to what extent X affect Y, right? We can make predictions so that at this level we can make a risk analysis, or we can use the information, or we can use the information obtained here for decision related to risk, right? Related to risk. And just we can say that here is the explanation of the two. For example, I just already explained it, but let me see one by one. Now, a risk analysis focuses on the future performance of the system. Always analysis, they care about the future, right? They care about the future. What will be the outcome of the future? Or a performance of a given activity tomorrow, right? As analysts, we only care about the future, right? Because we know the present and the past, right? The present and the past. So, in particular, some observable quantities reflecting performance of the system. Performance is Y. Observable quantities are X. Both should be measurable, right? Both should be measurable. We are at this stage. We are talking about this stage, right? We are talking about this stage. So based on the analyst understanding, based on the understanding of the world, we are going to develop a model, right? A model is something to use. A model is something to estimate using some values, some numbers or some data, right? Some data. And at the same time, we just, that is a model that relates the overall system performance. The model means which indicates the relationship between y and x, the left side, and this is the right side, right? The right side. And now we can predict x, the coefficient of x. Last time we called it is beta, or it's a vector of parameters, right? The vector of parameters. Well, the analyst assess uncertainties of x. Uncertainties of x here, right? Uncertainties of x. And that could mean the need for simplification in the assessment. Why we assess uncertainties? Because we want to make our analysis simplified. Unless we assess uncertainties, we cannot predict the model, right? We cannot predict the model. The end result of assessment of uncertainties is to specify probability, right? Why we assess uncertainties? Because we want to define the probabilities, right? The probabilities. So, using probability calculus, right? The uncertainty assessment of x, this one. Uncertainty assessment of x together with the model. We already developed here the model, which shows the relationship between y and x, right? Y and x. We can give result of the analysis, that is assigned probability distribution of y and prediction of y, x, right? Prediction of y. This is probability distribution and prediction y. Prediction means that's finding the exact magnitude of y. This is probability distributions, right? Probabilities distributions. Now, the uncertainty distribution of x. Uncertainty distribution of x and y are known as predictive distribution, right? Predictive distributions. So now, we make a risk analysis based on the uncertainty distribution of x and y. That is, we call it predictive approach, or predicting the distribution of the observable outcomes, right? The observable outcomes. Well, now using these 4 principles, how we can make analysis, risk analysis, or what steps we have to forward to make risk analysis based on these 4 principles, right? 4 principles. And here is the underline, or a typical step in risk analysis, particularly in risk analysis for business, right? For business. So there are at least 5 steps, typical steps in risk analysis. The risk analysis which has been made based on the 4 principles, right? Based on the 4 principles. The first step is we have to identify the overall system performance measures. Overall system performance measures. That means observable quantities should be determined at high level. High level means just identifying most important factor. Most important factor. And low level means we can say the low level we will take later. In fact, low level means the factors or predictable quantities, observable quantities with little effect, right? With little effect. So now the first thing is we need to identify performance measures or observable quantities at high level, which means identify y and identify x with measurable outcome, right? Measurable outcome. In short, we have to identify the determinants or the explained variable and explanatory variables or explained items. Explained and explanatory, right? Second one, we should develop deterministic model. That means we have to determine a model, or we have to develop a model which should be predictable, a model that can be predicted or estimated, right? Develop a deterministic model of the system, linking the performance measures and observable quantities. Performance measures means it is Y. Performance measure, it may be profit, it may be number of fatalities, or it may be a total volume of productions, or it may be production loss. Observable quantities, those items which affect profit, those those factors that affect fatalities for accident like risk, or factors that affect production loss, observable quantities. So the model shows the relation between performance measure Y and observable quantities X, X1, X2, like that, Xn. So the second step is we must develop adequate model to estimate the model that should be estimated and the result used for risk analysis. The third step is collect and systemize information about those low-level observable quantities. Right? At this step, high-level observable quantities are not the only factor that affect, or the only items that increase the likelihood of risk to happen. So we should do, or we have to collect and summarize the information about low-level observable quantities. Low-level means items that have an effect, but their effect is not as such significant or as such relevant for performance measures or to affect the performance measures. The fourth step is use probabilities to assess uncertainty of those observable quantities. Yeah, this is an important thing. The probabilities is we have to, unless we assign, by the way, unless we assign probability for uncertainties, it's difficult to measure risk, and it is very difficult to identify a risk from uncertainty. Uncertainty is, we can say, a qualitative, not quantitative, a qualitative expression of risk, right? A risk. So now at the fourth level, we should assign probabilities for uncertainties for all observable quantities, both high-level observable quantities and low-level observable quantities. Finally, or the fifth stage in the risk analysis process is calculate the uncertainty distribution of performance measures, right? This is the distribution of performance measures, which means the distribution of Y, not the distribution of X, the right-hand side, and determine suitable production for those distributions, right? Distributions. In short, the fifth step means estimate the model. Estimate the model or run the model using some softwares, right? Using softwares, especially for big data, right? Big data. So remember these 5 steps: identify overall system performance measures, develop or develop the model, then collect necessary information or data for low-level observable quantities, assign probabilities for observable quantities, and finally estimate the model. And the estimation result used to make decision related to risk, right? Related to risk. Now, having this procedure, right? Having these procedures, sometimes there is a situation where there is, or a risk analysis may face to develop a model, right? Which means maybe due to some difficult factors, or maybe due to the interest of the risk analyst, we may prefer not to develop a model, or not to make analysis or risk analysis using classical approach, or we can say using some quantitative form. So in such case, the analysis may directly transform historical data to uncertainty distribution, right? Just they took historical data, they observe historical data, and just transfer this historical data into uncertainty distributions and prediction related to the performance measures. What makes different here is step 2 and step 3 will be omitted. For example, here, if we are not going to develop a model, right? The step 2 and step 4 will be going to be omitted, right? Step 2 is develop the model, and step 4 is priority assignment, or assigning priority for uncertainties of the observable quantities, right? Observable quantities. Other 3 steps may be applied, right? May be applied because we need to have data. Step 4 is valuable. We have to collect the data, right? And because we already directly transfer the data into priority distributions, that means we are going to determine the distribution of performance measures, or distribution of Y based on the historical outcomes, right? Historical outcomes. So in other words, we can say the prediction are derived directly from historical data without using uncertainty distribution, which means we are not going to assign probability here. We just only predict based on the experience of based on experience data, right? Or based on historical data. In other words, the step 2 and step 4 will be omitted, right? Will be omitted, right? Will be omitted. In risk analysis, the main focus is on high-level performance measures. Please remember this one. In risk analysis, we often care about the most important factor that increase the likelihood of the risk to happen. However, we still concerned about low-level observable quantities. We have also some interest for those that have small effect, because X1 and X2 may have significant effect for the risk to happen, and X3 and X4 may have a small effect. And when we merge together, a small effect will have a significant effect like that of the high-level variables or high-level observable quantities. So even though we focus only high-level performance measures, in some cases we still have interest. We still have interest to compute the effect of low-level observable quantities. Low-level observable quantities means a variable which have smaller effect for the risk to happen, right? The risk to happen. Now, having this analysis, we are going to generalize the basic principle in risk analysis. So qualitatively, we can define the risk as uncertainty related to performance. ሰብለወንጌል ባለፈው አንሰርቴኒቲ ምናምን ብለሽኛል። ይሄ ኮንሰፕቱ uncertainty about performance. We call it risk in a situation when we make analysis qualitatively. In a quantitative sense, right? In quantitative analysis, we assigned probability for these uncertainties, right? Or we assign probabilities for observable quantities y, x1, x2, x something, right? X something. So in general sense, risk and uncertainties, they are different concepts. Especially the difference will be higher when we make risk analysis quantitatively, right? Quantitatively, not qualitatively. So we can say the risk is associated with the whole distribution of observable quantities or performance measures, right? Performance measures. And thus, we do have different summary means or summary measures for a risk. For example, we can use the mean, we can use the variance, and we can use the quantiles as a risk measures, which can give more or less information about the risk, right? So using mean, using variance, or quantile regressions or quantiles, they have the power to give some information about the risk, right? About the risk. So here is all about the principle of risk analysis, right? This is all about risk analysis. Now, the next step is what should or how to do risk analysis. Based on these principles and underlying steps in risk analysis, now how we can make analysis, right? Risk analysis quantitatively. Now, before that, we need to underline the importance of information in making risk analysis, right? In making risk analysis. As I said before, setting or assigning probabilities are the most important issue in making a risk analysis quantitatively. However, assigning probabilities are principally based on the information we have, right? Based on the information we have, the knowledge we hold, right? The knowledge we hold. We cannot simply put probabilities. We have to refer informations, right? We have to refer information and knowledge, right? Knowledge. So this information covers what information we have to consider. First, historical system or performance data, that is past data. Second, system performance characteristics, for example, policies, goals, strategies of the company, or we can say type of equipment to be used in case of product risk analysis, right? Product risk analysis. Knowledge about the phenomena in question, right? What will happen? Either the fire or explosion? Or what about how could human behavior affect, right? Decision made as well as model used to describe the world, right? The decision we are going to make and the model we used are an important information for assigning conditional probabilities, right? Conditional probabilities. Now, the other thing is we have to assume. An assumption is an important part of information and knowledge. We say that information and knowledge are the most important items we have to consider to assign probabilities. However, in selecting information and knowledge, or in using the information and knowledge, it should be based on assumptions, right? Assumptions are an important part of information and knowledge. For example, I'm going to directly read this one. An accident risk analysis, we may assume we are going to make analysis for accident risk. We may assume that no major change in safety regulation will be takes place. Unless we assume if there is major change in safety regulation, accident risk will likely to happen, accident risk will be reduced, right? For the time period considered. The plant will be built as planned for production analysis. The capacity of an emergency preparedness system will also be an important for equipment of certain types that has to be used, right? To be used. So in using information, assumptions are important. We have to assume important things, right? As I said before, for risk analysis, we have to assume major safety regulation will not be takes place. Thus, Assumption can be viewed as frame condition for analysis. They are a frame condition for analysis and produce the probabilities must always be seen in relation to those conditions, right? In relation to these conditions. If one or more assumptions are dropped, thus we would introduce some new elements of uncertainty to be reflected in the probabilities, right? So the inclusion or exclusion of assumption will reflect some change in our probability estimation or assigning probabilities. However, here we have to say that assumption change does not mean that probabilities are uncertain. This is the most important thing. We cannot say we assign probability for uncertainties, but the probability should not be uncertain. The probability we give, for example, before we say that 0.89, 0.1, and 0.01, we give a sign for the expected outcome 0, 5, and 100 respectively. So the probabilities are not uncertain. What is uncertain are observable quantities. The uncertain things are observable quantities, X and Y, not the probability, right? Not the probabilities. Now, having this, it's time to deal with how to develop model and simplification in probability consideration, right? Now we are going to use models for risk analysis and models and simplification in probability consideration. The fourth item of this chapter, right? The fourth item of that. So the general thing is to conduct risk analysis. It is often necessary to make some simplification of uncertainty assessment. Here, remember, the most difficult thing in risk analysis is to assess uncertainty or to determine probability, right? Probability. So if it is very difficult, we have to make some simplification. We have to make simple the way we assess uncertainty, or we have to make simple the way we assign probabilities, right? Probabilities. Now, simplification starts from defining or obtaining observable quantities. So let us see how we modeled risk analysis and how we can simplify uncertainty assessment. So the first thing is just deal with observable quantities. To make simple, as it is mentioned on the 4 principles, observable quantities should be state of nature or should indicate the world, right? Should indicate the world, meaning that they express the state of the world. Or in measuring observable quantities, there should not be ambiguity. Or the way we measure quantities should be true and objective, right? The way, one means of simplifying the model or simplifying uncertainty determination is making or take serious attention in measuring observable quantities, right? Observable quantities. That means, right? That means we should effectively solve measurement-related problem in risk analysis. If we make some measurement problem, our risk analysis will be complicated and we may arrive wrong inference, right? Wrong inference. So a true number exists according to the definition and availability of sufficient resources. It is easy to say our measurement is perfect, but it is difficult to be or to have a true state of nature means of measuring quantifiable outcomes or observable outcomes. So what matter whether our observable quantities are measurable or not is the way we defined the outcomes, the way we defined performance, and the availability of the information or resource itself, right? An example you can see here. For instance, a production company produces units, say mobile telephone, and suppose we focus on proportion of units that fail during a certain period of time. Now we produce mobile phone, and we are going to what? We focus on the proportion of units fail in the production process, accordingly to a certain definition of failure. So we have to define what failure means. Right? The production may face some problem in different degree, in different materials. So we have to define, we have to give a certain definition what failure means. Among all produced units in 1 year or other particular types of mobile phone, it says. So in this case, the proportion is potentially observable because we give what? A defined definition for what failure means, production failure means, since it can be measured exactly in sufficient resource available. However, in practice, that would not normally be done, right? Which means the way we define failure may not be normally done. And in fact, we can say we can classify the situations as unobservable. That means even though we give a clear definition, we still have practical problems to clearly quantify some issues, right? Some issues. Now, here, there is another concept related with observable outcomes. For example, in research, when you're doing research, you may use frequency analysis, right? Frequency analysis. Now, let's take this frequency analysis in the concept of risk analysis, for the concept of risk analysis. So, let's start our issue by questioning, what about a relative frequency? What is relative frequency? Can relative frequency observable, or is such a quantity observed, or is relative frequency a quantity observed? Right? In practical sense, there is issues. There is situations. The situation we are going to use frequency for risk analysis, right? Frequencies, and frequencies are often relatives, right? Relatives, especially when we use a kind of data or survey data, a data obtained using questionnaires like that. In such case, we use frequency analysis, relative frequency, right? Now, our question is using relative frequency. One thing, what does mean relative frequency? The other thing is whether relative frequency is quantifiable or it is a quantity observed and it can be used for risk analysis. Yes, to start, we can say it is, we can say no, or we can say yes, right? There is different situation where relative frequency can be quantifiable or observable, or there are situations frequencies cannot be quantifiable or observable and cannot be used for risk analysis. Now let's take an assumption. Assume the system is a production facility. The system means it is activity. We already defined at the beginning. Activity, for example, investment, right? Design, production is a system, right? So now we take here is assume a system is a production facility, and we focus on occurrence of an accident event for 1 year period. That is, the system is production facility, and we are now focused on occurrence of accident during a 1 year period. Based on this example, we can say whether relative frequency is quantifiable or observable or not. Now, based on this example, we can define relative frequency probability. This is relative frequency probability by the proportion of similar production facilities where this event occurs. You see, when we measure relative frequencies, here we refer what? The production of facilities where this event occurs, similar event we refer other similar events, not the current event. Similar event which already happened. No, right? Not the existing one or the expected one. So in order to define relative frequencies, it is a proportion of similar production facilities where this event occurs, right? If the population of similar production facility is just a thought means it is like an experiment or it is like a fiction, right? Fictional at experimental levels, right? Experimental levels. So in this case, relative frequency cannot be observed. So the question is where relative frequency can be observed. In order to have relative frequencies, which is quantifiable and observable and used for risk analysis, there should be a specific population determined, not experiment. We have to know the actual population can be specified. We have to specify the actual populations. Thus, the relative frequency can be viewed as observable. So, yes, when the population can be specified. No, when we refer similar experiences, or that is a kind of experiment, or based on some fictional ways, just an assumptions, right? Just some assumptions, right? So if the population can be specified, we can use relative frequency as observable and used for risk analysis. But if the frequency analysis is based on similar production facilities, or it is based on experiment, or someone's thought, experiment is someone's thought, or like fiction, we stand from some personal reasoning, right? In such case, it cannot be used for risk analysis, right? Risk analysis. Now, the question is, what is the real population and what is fictional population? Need to be determined in each application, right? Fictional estimation. We use the term fiction to explain relative frequencies which are not observable, and we use the term real population to express relative frequencies which is observable and quantifiable. So there is a general rule, right? In such case, we have to refer general rule. We should say that population may exist when we deal with repeatable games, right? Repeatable games, something frequently happened, used for a long term. Consider a trend. Or when we deal with controlled experiments, experiment may be controlled and uncontrolled experiment. So for populations that relate with quantifiable frequencies, we have to use control experiment, mass product unit, and large physical population like human being and others, right? Others. So in this chapter, we might focus on some, we are not going to apply the frequency, relative frequencies. We are dealing with other models, which is based on historical data, observable experiments, right? Observable experiments. So this is for an introductory part, and it is now a time to apply risk analysis or analysis for different types of risk, right? We are going to apply these principles, these steps, and we can say the information and knowledge required for assessing uncertainties. Do you have a question for the issues we have learned still now before I'm going for practical application? If you don't have a question, let's go to apply risk analysis for economic risk. We already learned what economic risk means in chapter 1 and even in chapter 2. No, at the beginning of chapter 2. So just at this level, we are not going to define what economic risk means. We already learned at the beginning of chapter 2. So we just directly go to how to apply a simplified version of risk analysis. So assume here a simple cost risk example. cost risk example. So I'm going to read the example and we are going to deal with the problem. So assume a risk analyst may be you and me in a company, is to assess investment cost Y. Is going to assess the cost of investment, which is denoted by Y, for a development project related to production facility. It is development project, and we are going to compute investment cost of a production facility. First, he would like to make an assessment based on historical records, right? As I said here before, in this slide, we are not going to apply frequency analysis. Rather, we are going to use historical records or observable quantities. So we are going to assess, he make an assessment based on historical record from 20 similar development projects, 20 projects, similar projects, which have been implemented to make analysis for the project which is going to be implemented to the future. And according to the 20 similar development projects showed that the mean cost, mean means average cost, is 100 and the standard deviation was 30. So this is a simple and the best example to make economic risk analysis. So remember, 20 development projects, estimation based on historical data from 20 development projects, and the data shows the mean cost of each project. 20 project is 100 and the standard deviation was 30, right? 30. Now the question is, how should he approach the problem? That means how he can estimate the investment cost, right? The investment cost. Well, we do have different approach to deal with this one. The first approach is using predictive approach, right? Predictive approach, which means the approach we are going to predict Y or make prediction of Y and assess uncertainties. Why we assess uncertainties? Why he assesses uncertainties? Because he has to set probabilities, right? Probabilities. So in this case, the mean of historical data is 100, which is a natural candidate for prediction of project cost Y, right? Which means 100 can be a value of Y to predict for prediction. We cannot predict X and Y without data. So we give 100 for Y for the purpose of prediction. However, he would stress that prediction of Y is based on only from 20 facilities. We have to remember, if we consider more than 20 similar development projects, let's say 50 projects, the value of Y may be different, right? So we have to consider a limitation that the value of Y, that is 100, the mean value, is determined for 20 similar development projects, which means if we increase the values of the number of projects, the value may be more than or less than 100, right? Right, 100. So to express uncertainties, the analyst may use histogram distribution. We already presented, right? We have to give express uncertainties in terms of histogram. You can say this histogram. This is probability. Probability is always between 0 and 1. And he give a similar weight for uncertainties, the outcome or the investment cost to be between 40 to 70, 70 to 100, 100 to 130, 30 differences, right? Difference. This is investment cost, which means he gives similar uncertainty or probability, the cost of investment between 40 and 70 might be 20% probability, and the cost to be between 70 and 100, it has a probability of 50. Here you can say here, and the cost to be 100 to 130, the probability is about 40%, and to be from 100 to 160, the probability is about 15, between 21, like this, or just it is a kind of assessing uncertainties based on prior experience, right? Prior experience. So the second way, so he can use predictive approach. The first one, using predictive approach, use 100 as a value of y and express uncertainties, right? Uncertainties. Secondly, he or she can use parametric distributions. And the parametric distributions, we assume the distribution is normal, right? To express uncertainties, parametric means we assume the distribution is normal or log normal distribution, right? Log normal distribution. So under normal distribution, in the use of normal distribution for economic risk analysis, we have to have two figures, at least two figures. The first, we should have the mean. Mean means the average value, which is 100 in our case. And we should have standard deviation, that is 30 in our case, right? The mean value for the cost of the project is 20 project is 100, and the average standard deviation for 20 project per project is 30. So for normal distribution, as you know, we use 95% confidence interval, right? 95% confidence interval we use. So we can set by the mean value plus or minus 2 times the standard deviation. So this is the mean value 100 minus this figure plus or minus 2 times standard deviation. Standard deviation is 130. So 100 minus 2 times 30 will be 40. And in the upper sign, we are using the 95 confidence interval, right? For the upper line, we use 100, the mean value, plus 2 times the standard deviation, 2 times 30, 60. It will be 160, which means at 95% confidence interval, right? At 95% interval, the investment cost, that is why we are going to predict, will be between 40 minimum and 160 at maximum. It is based on the historical data for 20 projects, right? So between 40 and 160, the value of y, the value of the investment cost. Now here we do this. There is no uncertainty related to the interval. We cannot say 95%. We don't have doubt about 95% is to be happened. We don't have doubt whether the interval is out of 95%, because there is no uncertainty related with probability. Prediction line uncertainty most ለማይቻል. All right, Masai.
አቤት ዶክተር። አቤት
እጅን አውጣ።
እዚህ ጋር ያልገባኝ እዚህ ጋር 95% የሚለው ኬት እንደምታ ያልገባኝ ሌላው
ኖርማል ኖርማል ዲስትሪቢዩሽን ሁሌ የምንጠቀመው 95% ኮንፊደንስ ኢንተርቫል የምንጠቀመው አይደል? ስታቲስቲክስ ኖርማል ዲስትሪቢዩሽን የቬል ሼፕ የሚሰራው በ95% ኮንፊደንስ ኢንተርቫል ነው። 5% ደግሞ ላይክሊ ዊ ጊቭ ሪስክ ቱ ሃፕን ራይት አውት ለሚሆን ማለት ነው። ስለዚህ አሳምፕሽናችን ምንድነው? at 95% prediction interval ይሄ u means just the mean value plus or minus 2 times the standard deviation. This is a common formula for normal distribution. The normal distribution የምንጠቀመው common formula, right? ለዚህ u ማለት ምንድን ነው? 100 ነው አይደል?
Yeah.
Right?
እሱ ግልጽ ነው። Yeah.
ቁጥሩ ቆጥራ አይደለ? 100 ነው። Upper interval ዝቅተኛ ኢንተርቫል ሲሆን በ95 ኮንፊደንስ ኢንተርቫል less likely to happen የሚሆነው ምንድን ነው? u 100 that is the mean value plus 2 times 30 60, right? ስለዚህ ይሄ 100
40
minus 30 we get 40, right? በ95% ኮንፊደንስ ኢንተርቫል the cost of y a minimum to be what? 40 ነው የሚሆነው ማለት ነው, right? ቢያንስ 40 ነው, right? በ95% ኮንፊደንስ ኢንተርቫል the cost of y ስንት ነው የሚሆነው? 40 ነው.
40
በማክሲመም ደግሞ ምንድን ነው የሚሆነው? ፕላስ 100 ፕላስ 2 times 30 60 160. የትኛውን ያልተግባባ ነው መሳይ?
አይ አሁን ገብቶኛል።
ገብቷል አይደል?
95 የምትለዋ ነበረች።
it is common formula ለ95% normal distribution ሁሌም የምንጠቀመው 95% confidence interval in statistics, right? normal distribution ሲሆን በዛ ነው። ይሄ ደግሞ upper እና lower limit ዲተርማይን ለማድረግ የምንጠቀመው ፎርሙላ ነው, right? all right. so why
እዚህ ላይ አንድ ነገር በቀደም this is a 95% confidence interval. In this case we use the classical approach as we said last week. But when we said in a Bayesian approach or a subjective approach, we use the credit intervals.
Yes.
What's the difference between them? This is
that's important. Credit interval difference ye predict confidence interval na credit interval ya define አድርገናል already. confidence creative interval የምንለው በባይጂያን አፕሮች ሰብጀክቲቭ ነው አይደል? ያልነው ሰብጀክቲቭሊ ነው። ኢንተርቫሉን ወይም ደግሞ ክሬቲቭ ኢንተርቫል የምናስቀምጠው ሰብጀክቲቭሊ ነው የምናስቀምጠው። ሰብጀክቲቭ ፕሬዲክሽን ነው ያለው። ሰብጀክቲቭ ፕሬዲክሽን ደግሞ ብዙ ሚንሶች አውጥ ተዘጋናት እና ምንድነው አሳም የሚያደርገው ይሄ ክላስ አሁን ባለፈው ነግራችኋለሁ። ዘ ኢንታየር ከዚህ በኋላ ያለው ቻፕተር በሙሉ ምን እንደምንጠቀመው ያለው ክላሲካል አፕሮች ነው ያለው አይደል? ባለፈው ቻፕተር ውስጥ ተናግሬያለሁ። ምንማረው እስከ አናሊሲስ በተግባርም ያለው ክላሲካል አፕሮች ነው። ስለዚህ ባይጂያን አፕሮች ሰብጀክቲቭሊ ዲፋይን ያደርጋል። ምክንያቱም ፓራሜትሩ አንኖን ነው። አንኖን የሆነ ፓራሜትር ኖን የሆነ ክሬቲቭ ኢንተርቫል እናስቀምጣለን አሳምፕሽን ስላለ ነው። በክላሲካል አፕሮች የምንጠቀመው ምንድነው? the parameter is unknown, right? the parameter is unknown. It might be evenly distributed or not, right? the distribution parameter fixed ነው unknown ሁለቱም ሆነ አይችልም either fixed or unknown, right? the parameter የምንለው ቤታ ነው, right? ቤታ እቺ ሪስክ ሜጀር የምናደርግባት ናት ቤታ the coefficient of x, right? the coefficient of x assumption ያ ነው። ነገር ግን generally in statistics ወይም ደግሞ በክላሲካል ሊኒየር ክላሲካል ሪስክ አናሊሲስ አፕሮች የምንጠቀመው በአብዛኛው የምንጠቀመው የ95% ኮንፊደንስ ኢንተርቫል ነው። ኢንታየር ሶፍትዌር ሁሉም ሶፍትዌሮች whether we use SPSS, whether we use Stata, whether we use EDUs, quantitative analysis የምንሰራባቸው ሴታፓቸው 95% ኮንፊደንስ ኢንተርቫል ነው። 95% at 95 confidence interval they try to set normal distributions. ያን ስለሚያደርጉ ነው ይሄ ስታቲስቲክስ ነው ሞር ተደሪባ ምናልባት ይሄ 95% ኮንፊደንስ ኢንተርቫል ዲተርሚኔሽን አይነት ነገሮች እሱ ሞር ወደ ስታቲስቲክስ ፕሪንሲፕል ኦፍ ወይም ደግሞ ኢንትሮዳክሽን ቱ ስታቲስቲክስ ተማሩ ወይም ደግሞ ሪሰርች ሜተድ ላይ ሊታወቅ ይገባል። anyways assumption
እሱ ገብቶኛል በስታቲክስ ጀስት ቱ ስታንዳርድ ነው ሄዶ ይሄ 95% ኮንፊደንስ ኢንተርቫል ነው 3 ከሆነ ደግሞ 99.7 ይሆናል 1 ከሆነ 68 something ይሆናል እና እሱ ግልጽ ነው ምክንያቱም እንትኖቹ ነው የምንፈልግበት ነው በዚህኛው በኖርማል ስታቲክስ በክላሲካል ሜቶዱ ማለት ነው ግን እዛኛው ላይ ክሬዲት ኢንተርቫል ስላለና አሁን ደግሞ ጠቅሷል ከላይም ቅድም ሰብጀክቲቭ አፕሮችስ እንጠቀም የምትል ነገር ስላለች ለነኚህ ነገሮች እንዴት እንጠቀማለን የሚለው ነገር ነው እና ኢቭን ደግሞ ፍሪኩዌንሲ ስንጠቀምበትና ላይክሊሁድ ወይንም ፕሮባቢሊቲ ስንጠቀም ጀስት ፎር ክላሲካል ነው ይላል ለዛኛው ደግሞ ፍሪኩዌንሲን ተጠቅመን የምንሰራቸው ደግሞ ወደ ሰብጀክቲቭ አፕሮቹ ነው የሚመጣ ስለሚል እነዚህ ነገሮች እንዴት እናገኛለን ከዛኛው ለማለት ነው እንጂ ግልጽ ነው እዚህኛው ይሄ ግልጽ ነው
So what I mean is just is a default setup ነው በዛ እንትን ብለው default 95% as it read የምንጠቀመው ቱቴል ስለሆነ እዚህ ጋር ኖርማል ዲስትሪቢዩሽን 95% ኮንፊደንስ እናልፋለን ነው እያየን ያለነው ከምን አንፃር ነው ከፍሪኩዌንሲ አናሊሲስ ሳይሆን ሂስቶሪካል ዴታ ነው right ሪሌቲቭ ፍሪኩዌንሲ ሳይሆን ሂስቶሪካል ዴታ ነው ኤግዛክትሊ እንትነን ጥያቄን በደንብ አላገኘሁትም ደሪባ ለመመለስ ኤግዛክትሊ ማለት ነው
አይ አሁን ነገሩ እኔም አዋለው ምክንያቱም እዚህ ላይ እንትን ሳንለው እነዚህ አሁን 95% ኮንፊደንስ ኢንተርቫሉ በዚህ በክላሲካሉ ግልጽ ነው ይገባኛል እነኚህ ስላየዋቸው ማለት ነው ወንም ደግሞ አልፋ ቫልዩ 0.05% ሊሆን ይችላል ማለት ነው ችግር የለውም በዚህኛው ግልጽ ነው ግን
በባይኖሚያል አፕሮች ራንደምሊ ሴሌክት ስለምናደርገው ምክንያቱም እቺ የፓራሜትሯ ማለት ነው ፓራሜትር አሳይን ስናደርግ ፓራሜትሯ ምንድነው የሚለው just this is both random and known value ነው የሚሉት በአሳምፕሽን ቤዝ ለዛ እኮ ነው በባይኖሚያል አፕሮች ማንጠቀመው አንደኛው የአሳምፕሽን ችግር ስላለበትና ማቴማቲካሊ ኮምፕሊኬት ስለሆነ ነው ለመደበኛ ሪስክ አንጠቀምበትም ያልነው አንደኛው ዊክነስ የባይኖሚያል አፕሮች ፕሮባቢሊቲ እነዚህ ኮንፊደንስ ኢንተርቫል ሴት የምናደርገው ቤዝድ ኦን አሳምፕሽን ሰብጀክቲቭ አሳምፕሽን ነው የምናስቀምጠው ሰብጀክቲቭ አሳምፕሽን ክሬቲቭ ኢንተርቫል የሚባል ያስቀምጣል ክሬቲቭ ኢንተርቫል ደግሞ ምንድነው ራይት ቫልዩ ነው ላስ የሚያደርገው ዛኛው ራይት ቫልዩ ነው እና ይሄ ደግሞ ክሬቲቭ ኢንተርቫል is a kind of both fixed and random ነው የሚለው ዲፈረንስ ቢግ ዲፈረንስ ያለ ይሄ both fixed and random አድርገን ከወሰነው ፓራሜትሩን ማቴማቲካሊ አፕሊኬሽን ኮምፕሌክስ ይሆናል አንደኛው የባይኖሚያል አፕሮች ትልቁ ፕሮብለም ማቴማቲካል አፕሊኬሽን ነው it is based on a lot of assumptions በእያንዳንዱ ስቴፕስ እንደርስ አሲም ያደርጋል for classical analysis as we all of you know it's just quantitative analysis ወይም ደግሞ confidence interval predict ስናደርግ we have known values and for the known values for example 95% confidence interval we use the same formulas for other types of confidence intervals 95% confidence interval default zone software ላይ default ነው ለሌሎቹ ግን for strict analysis we may use 1% 99% or for linear analysis we can go beyond the predictive interval maybe less than 95% right 95% ነገር ግን entire analysis በክላሲካል analysis assume ተደርጎ የሚሄደው confidence interval or prediction interval within 95% ነው የሚል ነው በዛ ኬስ ለምናየው ነው actually የባይኖሚያል አፕሮች በዚህ እንትን ውስጥ አንማረው ስለማንማረው ኮምፕሌክሲቲም ስላለበትና ለከረንት ሪስክ አናሊሲስቶች ቤስት ፕሪፈረብል ስላልሆነ አናየውም ለዛ ነው እና አንደርስታንድ ያደረግነው so we are here so we can say here an important thing you have to remember is ምናልባት እዚህ ጋር ክሊርሊ ማወቅ ያለባችሁ probability uncertain አይደለም right here is probability 95% uncertain ነው ብለን የምንል ከሆነ ሙሉ ፕሮሰሳችን ምንድነው የሚሆነው wrong ነው የሚሆነው right weight ስንሰጥ outcome ቅድም ያልነው outcome to be 0.89 ብለናል outcome to be 5 0.10 outcome to be 100 0.01 ሰጥተናል እነዚህ ፕሮባቢሊቲዎች አንሰርቴን ናቸው ብለን ካሰብን መስራት አንችልም with assumption is probabilities are not uncertain or probabilities are certain what is uncertain is the parameter of observable quantities or the value of x or the parameter of x1 x2 x3 like that and even the outcome right እዚህ ጋር የሚያስቀምጠው ምንድነው there is no uncertainty related to interval that is 95% interval and there is no meaning in speaking of uncertainty of parameters u the mean and standard deviations because such reasoning will presuppose the existence of true probabilities which do not exist in this setting ይሄ በጣም ኢምፖርታንት ነው right 95% ኮንፊደንስ ኢንተርቫል አንሰርቴን ነው ካለ the entire analysis wrong ነው የሚሆነው ስለዚህ always in the classical approach we assume probabilities or assessment of uncertainties are known nature they are certain right they are certain so here say we use two approach for this analysis the predictive approach and the parametric distribution approach however in terms of result both whether we use histogram or normal distribution to fix the value of the mean and the standard deviation there is no that much differences parametric distribution የምንጠቀም predictive analysis የምንጠቀም ምንድነው there is no difference in the values of mean and standard deviations so we can say for the analysis we can use either parametric distribution or like that of normal distribution በነገራችን ላይ log normal የምንለው ቫልዩን ይሄንን 100 እና 30 ወደ log መቀየር ነው right ሌላ ፎርም የለው log normal ወደ ቫልዩ ወደ ሎጋሪዝም ቀይሮ አሳምፕሽኑ ግን ኖርማል ዲስትሪቢዩሽን ነው ወይም ደግሞ አንደር ፓራሜትሪክ ዲስትሪቢዩሽን ነው parametric distribution assume የምናደርገው the values are normally distributed now right normally distributed so for this analysis we can use uncertainty expressions or predictive approach or we can use normal distributions or non-normal distributions right distributions so now however the use of normal distribution and log normal distribution has large uncertainties ችግሩ ይሄ ነው አሁንም 95% ኮንፊደንስ ኢንተርቫል አንሰርቴኒቲ የለውም እንበል እንጂ right የለውም እንበል እንጂ still normal distributions and normal distributions even predictive approach there is still uncertainties because the investment cost is based on rather limited information and knowledge ይሄ ነው ትልቁ ነገር right ኢንቨስትመንት ኮስትን ለምሳሌ በዚህ በፕሪዲክቲቭ አፕሮች ለማን ነው በኖርማል ዲስትሪቢዩሽን the value of y will be lie between 40 and 60 ነው በ40 እና በ160 መካከል ነው ለናል ይሄ ግን ሰርቴን አይደለም ለምንድን ነው ሰርቴን የሚሆነው አንሰርቴኒቲ ያለው ይሄ value to be አንሰርቴኒቲ ነው ለምንድን ነው we still based on limited information የምንጠቀም ኢንፎርሜሽን ሊሚትድ ነው for 20 experience ነው ወሰነው similar projects right not projects so why normal distribution and predictive approach has uncertainties because we use limited information so how we can reduce this uncertainty is another question ስለዚህ ሁለቱም ሜቶዶች uncertainty አላቸው ካለን how we can reduce uncertainties actually we cannot completely avoid uncertainties avoid ማድረግ አንችልም ስለዚህ we can only reduce right reduce so one of the best way to reduce uncertainty and obtaining narrow prediction means ቀደም ታው በ40 እና 160 ነው big difference አለ right narrow prediction interval is to identify that are important determinant to the cost, which means we have to identify key factors related to production facilities. It is not only one factor, we have two key factors. High level and low level. Right? So we have to rigorously identify other factors which could affect production facilities. Right? Production facilities. For example, right? And instead of the observations, production volume may be one factor which increase investment cost. Why? Then we can make, at this level, we want to appreciate how important to develop a model. Distribution based which is our model and develop ሌሎች ፋክተሮችን እናስገባ። For example, production volume 100 ስናመርትና 100,000 ስናመርት the cost of Y may not be fixed, right? May not be fixed. So we have to consider other factors. ይሄ የሚያሳየው the importance of developing a model which consider more than one factors, which considers beyond historical data distributions, which considers the determination of probabilities other than the historical data, right? The historical data. Therefore, let us go to how we can solve these problems. Now, we are going to develop a model. So suppose that the data fit well to a straight line, which means we use a linear expression y equal to alpha plus beta of x, right? This is the constant, and b is the parameter. This is the coefficient of the parameter x, right? Which represent straight line in the ordinary least square regression, right? And sessions. So x is an input. It may be production volume or other variables, right? And y is, you call it, this is the cost we are going to estimate, investment cost. Y is investment cost. A is, we just fixed it, that's the constant effect. And beta is the coefficient of the parameter x, right? Parameter x. And x may be, as I said before, volume of productions and other factors. Based on this model, we may use standard regression analysis to produce empirical variance for investment cost. Why we use this variance? Because variance is a measure of risk, right? Variance, we can use variance, we can use mean, we can use standard deviation as a measure of risk. So this is the formula how to determine variance from the ordinary least square. That is 1 minus 1 over 1 n minus 2. N means just number of experiences. That is the number of previous projects which have similar nature. And this is summation of y, the value of y, we just is the dependent variables minus the constant minus beta of x squared. This is just the way how to determine variance of investment costs. Just remember the formula, right? Just remember the formula. So performance measure in this case is the investment cost of y, which means defined according to the standard econometric convention. Means there is some criteria that has to be satisfied to measure the dependent variables, right? Dependent variables. Then the model is developed linking this investment cost y and more detailed cost elements, which means x means the factor that affect the cost of the investment, right? X, I, 1, 2, 3, or k. We can say the number of variables determined based on the items that affect the costs, right? The costs. So in this case, the model is simply the sum of the cost element, which means how we do just the model y equal to summation of xi for k natural number, and just k is the number of n, which means 20, and for n is equal to 1 starting from natural number, right? Natural number. Well, as a predictor for the cost of y, we could normally use the mean. We use the mean, right? Mean of y, which means the mean value of all factors that affect the cost. That means the summation of all means value of x, the mean value of x, right? The mean of y equal to the sum of the mean of x. That is the predictor, right? That's the predictor. So this is straightforward, and the challenge is to establish the uncertainty related to y. In compute mark mean of x determine to find the mean of y. The challenge is how to establish uncertainty to the value of y. And then study method uncertainty determine. That's a big challenge, right? A big challenge. So generally, we can say the basic thinking about the use of model and other historical data distributions, either it's a predicting approach or normal parametric approach, right? The parametric approach, we are going to summarize the thinking, right? First one, for each cost element I. Cost element means just, we can say in the previous example, x, x1, x2, x3, x4, like that. A probability distribution of Fi, this is probability for each one. Probability of x1, probability of x2, probability of x3 is determined that expressed the analyst uncertainty related to the value of xi, right? So probability assigned will let this uncertainty related to the value of xi. Thus, the distribution is established based on historical data and expert judgment, which means the distribution of x. The value of x will be determined based on historical data, or it can be rationally determined by judgment, right? Judgment. So in practice, the distribution of y is often found by Monte Carlo estimation. Might be. Do you have experience about Monte Carlo estimation? ከዚህ በፊት ስለ ሞንቴ ካርሎ ስቴሽን ታውቃላችሁ? ይሰማል?
አዎ ይሰማል።
ስለ ሞንቴ ካርሎ ስቴሽን ተማራችሁ ታውቃላችሁ?
ይሰማል።
So practically distribution of y, the value of the costs. The cost of the project determine ያደረገው ሞንቴ ካርሎ estimation ነው። this estimation ያለው statistics ራሱን የቻለ ዳታ አለ። ሞንቴ ካርሎ ዳታ በዛ estimation procedure ነው determine የሚደረገው። ሞንቴ ካርሎ estimations chapter 5 ላይ አለ፣ ግን we are not going to apply the estimations because we need to have some data to apply these estimations. Anyways, practical distribution determine ለማድረግ ሞንቴ ካርሎ estimation እንደምንጠቀም የሚያሳየው። ሞንቴ ካርሎ it's a kind of estimation procedure ነው፣ ሌላ ነገር አይደለም። ሞንቴ ካርሎ estimation የሚባል estimation techniques አለ። ያን ቴክኒክስ በመጠቀም distribution determine ማድረግ ነው። we will see about Monte Carlo estimation in chapter 5. በጥቂቱ ነው የምናየው። ይሄ በጣም ብዙ ኮምፕሊኬትድ ነገር ሳለ በጥቂቱ chapter 5 ላይ እናየዋለን። So normal distribution are often used to reflect uncertainties, right? Uncertainty determine ለማድረግ reflect ለማድረግ we use normal distribution. The distribution of y and compute ለማድረግ ደግሞ Monte Carlo estimation practically እንጠቀማለን ማለት ነው፣ right? Practically እንጠቀማለን ማለት ነው። So the other item of this chapter is how to apply risk analysis for business and project management issues, right? Just it is a kind of an introduction. We are not going to apply the practical one because the practice we have been used for risk analysis is a part of business and project analysis and the partner. So here, as your course level indicates, we have to see how to make business and project analysis, right? Risk for business and project management, right? So, and actually the standard approach to risk and the risk analysis in business and project management is almost similar to the one we have seen in section 3.1, that is basic principles. የተለየ ፕሪንሲፕል አይፈልግም። ቢዝነስ እና ፕሮጀክት አናሊሲስ ሪስክ አናሊሲስ መስራት መጀመሪያ ያየናቸው 4 ፕሪንሲፕሎች 5 ስቴፖችን follow ማድረግ ነው right 4 principles 5 steps right 5 steps what we have learned in the first sections of this chapter. Now let's take an example, right? Just a very simple example. If you are going to invest a certain amount of money in a certain business, you are considered about the cash flows, right? So in the concept of business and project management, the most important thing is we have to predict cash flow, right? Let us denote cash flow Y. That is the dependent variables in the model, the left-hand side. Based on an evaluation of cash flow for this business in previous years, you could make prediction of Y. Prediction of Y means what will be the cash flow in next year, next 2 years, next 5 years, like that. This is our interest, right? This is our interest. Unfortunately, we cannot make prediction of Y unless we make assessment of uncertainties related to Y. Expect ማድረጉ ብቻ አይደለም. So the important thing is, but we have also like to see an assessment of uncertainties. Value ብቻ ሳይሆን we care about uncertainties, which means that we may estimate 100,000 project return, and we are not sure. So we care about uncertainties, whether we really achieve 100,000 or not, right? So such analysis can be made in different ways, right? In different ways, as it has been discussed in the previous section. The first one is we use a probabilistic expression. That means expressing probability of having cash flow of at least Y, right? To be what? We give a probability for an assessment of uncertainty Y to be 100,000. That is what? Assigning probabilities, expressing uncertainties in terms of probability. We are 95% confident that the value of 100,000 to be true, right? To be true. The other thing is, instead of probability expression, we could investigate number of time period where the cash flow has been of certain amount. This means what? We could increase in the number of time periods, which means just over the long runs or the period where the cash flow has been of a certain amount. የቀኑን በማየት ለምሳሌ የ20 ዳታ ነው ቀደም የተጠቀምነው 20 ፕሮጀክት ነው። ለዚህ ከ20ዎቹ ውስጥ certain result ያገኙትን we may focus on that data. In such case, we could have a better informations, and we could have a good prediction, right? Good predictions. That means considering time, the cash flow over the period, not only one time, over the periods. ቀድሞ ከዚህ በፊት ባለን ኤክስፒሪየንስ እንትን የምናደርገው ከዚህ በፊት ያለን ኤክስፒሪየንስ ምን ያህል እስቲሜት አድርገን ምን ያህል ፐርፌክት ሆነ ነው። ስለዚህ ፎከስ የምናደርገው the previous result where expected cash flow equal to the actual cash flow. ለምሳሌ 20 ዓመት ከሆነ ከ20 ዓመት ውስጥ ምናልባት 5 ዓመት ያቀድነው ካሽ ፍሎው እና አክቹዋል ካሽ ፍሎው እኩል ሊሆን ይችላል። ያን ዳታ በመጠቀም we can make predictions. ይሄን በምናደርግበት ሰዓት we will have better informations, and we can make easier to produce good predictions, right? Good predictions. Now suppose we express our uncertainty related to the value of Y. Y is cash flow by the normal distribution with mean and variance. Mean 100,000 and the standard deviation is 30, right? We use here mean and variance 2. According to our predictive approach, we just remember the predictive approach. We use the mean values, right? We only use the mean values 100,000, right? And speaking of the uncertainties of the parameter, right? Parameter. So as a consequence, the phase estimation of this parameter should be with care, which means when we use predictive approach, we have to care about the estimation of the parameter. The parameter parameter means x1, x2, x3. Estimation of the parameters and measurement of the parameters we should give attention. So what is certain is y, what is uncertain is y. And it is meaningless to discuss about the correctness of the use of normal distribution. 95% correct ነው አይደለም የሚለው ነገር ልንጠቀመው አንችልም. Because probability are not uncertain. Right? What is an uncertain is the outcome. Right? The outcome. So እዚህኛው ላይ ቢዝነስ ፕራክቲስ ላይ አንጠቀመው ቅድም ካየነው ጋር the same example ስለሚሄድ አናሊሲስ ለመስራት ነው. Now let we use investing money in stock market as an example of risk analysis. ይሄ ምናልባት very important ሊሆን ይችላል because we are going to opening stock market in the future. Ethiopia is preparing to open stock market or secondary markets. So it is very important to make comparison between investment in stock, right? Different stocks. So assume person S, a person named S would like to invest $2 million in the stock market. We can give the name here, right? Someone name, right? For example, you can say Salongel would like to invest $2 million in the stock market. And she considered two alternatives. The first alternative is she wants to buy stock of type 1 only. She prefer to invest all the $2 million for one types of stock. Only one types of stock. Maybe the stock of, assume the stock of Apple, right? Or she may decide to, another alternative is she may in between to buy stocks type 1 from here half and type 2, another types of stock. For example, here is from Apple and from here from Samsung. She wants to invest with 50% on each. 50% means we have 2 million, 1 million investment for type 1 and 1 million investment for type 2 stock, right? Type 2 stock. Thus, before she decide what to do, she conduct a risk assessment according to the unifying principles. You remember the 4 principles, unifying principles. So she focus on how the value of the stock next year. We only care about the future values. When we invest today, we care about the future values. So let's denote the next year value of the stock, types of stock type 1 will be X1, which means return from investment from type 1. That is Apple. And the corresponding next year value of stock 2, that is from Samsung, assumed by X2. Both have a value of $1 million. Apple and Samsung, which she invests $1 million from each stocks, right? Now let Xi denote the total value of the stock next year, which means the value of the stock. I is always our focus. What should be tomorrow? So alternative 1 and 2, type 1 and type 2. Thus we have y1 equal to 2 times x1. Why we say y1 2 times x1? Because we have 2 million and we invest the 2 million in one investment. So we just 2 times x1. She buy 2 types of stock, 1 types of stock, right? From type 1, right? That means she invests the 2 millions in x1 or type 1. X1 means the value of stock 1 next year. And the value, so the present value of type 1 stock 1 in this year. And return from type 2 investment 2 means 1 million from type 1 and 1 million from type 2. The return would be x1 plus x2, right? Because x1 is the next year value of stock 1 or type 1 investment, or x2 is the next year value of type 2 investment, right? Type 2 investment. Wait, so Now, Savlewangel may looks at historical records in order to make analysis. She may go to see the return trends of investment type 1 and investment type 2. And she may make analysis for the corresponding companies, policies, strategies, plans of the future. Based on the information, she predicts the future value of the stock and assets uncertainties, right? Uncertainties. Now, which means we have to consider prior records or prior data and consider the companies, company A, that is Apple, company B, that is Samsung, their policy, strategy, and plan, because it affects the future return, right? The future return. Now, a normal distribution, we are used to express uncertainties. So if you use normal distribution, we have to express uncertainties. Hence, it is efficient to specify the mean and the variance. Normal distribution ላይ የምንጠቀመው mean እና variance ወይም ደግሞ standard deviation የምንጠቀመው, right? In variance. For predictive approach, we only use the mean values, right? In the values. So suppose this assessment gives the same means, and we assume what? The means for the investment, right? The mean value of x1 equal to the mean value of x2, which equal to 1.1 million each, right? Then she predicts the same value for the two alternatives. That means, according to her prediction, the value of x1 and the value of x2 is equal. If she invests in x1, she will going to invest the whole 2 million. So the return will be 1.1 times 2. That's the 2 millions, right? And it's going to be 2.2 million. And if she's going to invest for type 1 and type 2 stock in Apple and Samsung, because the return is equal, we can say 1.1 plus 1.1 equal to 2.2. In other case, she estimates the future or the mean value of the investment from both type is equal, right? From both type is equal. Now, beyond the mean, we have to care about the variance, because we use normal distributions. Normal distribution, we use both the mean and the variance. Well, suppose the variance also the same. The variance of x1, investment return from x1, and variance of return from x2 equal to 0.04, the same, like the mean, which has been equal to 1.1. Both the mean and the variance of the two investment type are equal. Still, we assume this is an assumption. So for this, we see that for variance of investment 1, where we spend the whole 2 millions in a single stock, 4 times the variance of x1. 4 means, here we have to remember things. 4, we have variance of x1 investment for 1 million and x1 and x2 from type 1 investment. We have two things, 1 million for x1 from type 1 and 1 million x2 from type 1, right? We have variance of x1 and variance of x2. And similarly, both x1 with 1 million and x2 with 1 million, they have covariances. The covariance means the likelihood how two variables change together, move together. Covariance means moving together ነው። x1 እና x2 እንዴት ሙቭ ያደርጋሉ? አራት ከየት መጣች እንዳትሉ ነው። 4 means variance of x1 with 1 million and variance of x2 with another 1 million, and we have what? The two covariance, x1 and x2 have two covariance. 1 plus 1, 2 plus 2, we use 4. So equal to 4.16 under the case of investment 1. For variance of 1, 2, we use x1 with 1 million, x2 with 1 million, and we have the same covariances equal to 0.04. 0.08 means 0.04 plus 0.04, we get 0.08 plus the 2 times covariance of x1 and x2. The covariance here is represented by the correlation coefficient. Covariance measure የምናደርገው the correlation coefficient ነው. Let's denote by what? This is assume the delta, which is a correlation coefficient between x1 and x2, right? So 0.08 plus delta times 0.08 equal to this figure, right? This figure. Now compare 0.06, 0.16 and 0.01. In fact, so 0.08, which is conditional to the value of the coefficient, right? Conditional coefficient to high, low zero, and conditional. So compare only 0.16 and 0.08. Based on this variance, we can conclude that the variance of y2 here, 0.08, is smaller than the value of y2, 0.16. The lower the variance of means, in fact, the variance of y1 is dependent on the correlation coefficient, which is unknown here, right? Which is unknown here. So we have lower variance in the case of alternative 2, investment alternative 2, with stock 1 and stock 2, type 1 and type 2, low variance. And here we have the same investment, the entire 1 million is invested in type 1, 0.16, which means the variance is high. So thus, if Sabalongil assign a correlation coefficient of this one, the size is 0, the variance of y2, 0. Make 0 this one. 1 plus 0, 1. 1 times 0.08, 0.08, which is less than this one. So we can conclude that the variance of y1 is greater than the variance of y2, right? Greater than the variance of y2. The higher variance means the higher the risk. So we are going in favor of investment 2 than investment 1, right? Investment 1. Now here assume that here is the very simplified types of analysis because we consider the mean is equal and the variance is equal. In a situation where we assume different mean and different variance, the analysis will definitely be very complex, right? Very complex. Very complex. This one is a simplified version. Actually, simple analysis in a market like Ethiopia, where the market is smooth, right? Just if you invest something, you're going to earn some amount, which is better amount, because the market is not well explored. We can use analysis, a simple analysis like the one we did, right? The one we did. However, in complex environment or in a market where when there is intense competition, we have to consider different mean for different investment and different variance for different investment. In such case, the use of such simple analysis is very difficult. So we have to go to with a multiple linear regression analysis or other types of multiple analysis, right? Multiple regressions, right? Multiple regressions. So we can say here uncertainty or risk are consequently smaller for alternative 2 because the variance is lower than for alternative 1. But this does not lead to a recommendation on which alternative to choose. The risk presentation here reported to the variance is just an input for decision making. So variance is in the input now, right? For decision making input now. Absolute reliance in basic case. What is the best alternative must be seen in relation to policies. You see, we have to see the policies of type 1 investment and type 2 investment, preferences and attitude towards risk and uncertainty. The important point is that uncertainty can be reduced by diversification. Why the variance of y2 is lower? Because we have 2 segments of investment, type 1 and type 2, which means we diversify our investment, right? We diversify our investment. In fact, in chapter 4, we will discuss about portfolio and portfolio theory and diversification in the Marala. We will see next chapter, in fact. So diversification is an important. That is investment in stock securities from a number of companies in various industries. The last issue in today's lesson is we have to take note some of this. Note that the analysis in this example does not depend on the use of normal distribution. as long as we agree on using variance as a way of representing the speed of distribution. If the analysis in this example had give different means and different variance, the decision situation would have been more complex. I already tell you. Alternative 1 may have higher mean and also may have higher variance than alternative 2. So to decide, we could need to take into account relevant policies, preference, and attitude towards the risk. For an investment holding diversified portfolio securities, the mean of uncertainty distribution related to the value of security is normally distributed or specified as return from securities in the market as a whole. So finally, we have to say uncertainty distribution is then characterized by the spread of distributions, and thus the spread can be measured by the variance and quantiles. Quantile regression መጠቀም ወደ ሌሎች complicated regression ላይ እንዳለብን ነው discuss የሚያደርገው. This is all about today's lesson. Tomorrow we will see the uncovered section of the chapter, that is the use of discount cash flow analysis and accident risk. So thank you for today's lesson.
ልዩነት መፍጠር ዓላማችን ነው። ዓለም አቀፍ ተወዳዳሪ መሆን አለባችሁ። የናሽናል ኤርዌይስ እህት ኩባንያ ናሽናል አቪዬሽን ኮሌጅ ጥራትና ደረጃውን የጠበቀ ስልጠና በመስጠት ብቁ ዜጋ እያፈራን ነው። በፍላይት ኦፕሬሽን፣ በበረራ መስተንግዶ፣ በቲኬቲንግና ሪዘርቬሽን፣ በሆቴልና ቱሪዝም ሙያዎች አሰልጥነን ተወዳዳሪ እናደርጎታለን። ኮሌጃችን ካናዳ ከሚገኘው ኢንተርናሽናል ኤር ትራንስፖርት አሶሲዬሽን አያታና ከእንግሊዙ ICM ጋር በመተባበር ዓለም አቀፍ ዕውቅና ያለው ስልጠና እየሰጠ ይገኛል። በፍላይት ኦፕሬሽን፣ በበረራ መስተንግዶ የምንሰጣቸው ስልጠና ከኢትዮጵያ ሲቪል አቪዬሽን ባለስልጣን ሙሉ ዕውቅና አለው። አድራሻ ከጎላጉል ታወር 22 አደባባይ ወደ ሾላ በሚወስደው መንገድ ላይ የናሽናል ኤርዌይስ እህት ኩባንያ ናሽናል አቪዬሽን ኮሌጅ ህልሞን